Okay, so let's take a look at the answer for this. So the first step is to assign oxidation numbers for everything. Okay, so that's something you have to feel comfortable with. So in this case, so these are pretty straightforward to assign, right? Normal rules. Now sulfur here is not in its elemental form, but it's only one atom, like it's only one sulfur, and it's neutral. There's no charge on it. So automatically that's going to get assigned a charge of 0, because if it's not an ion and it's alone, it can only be 0 to add to 0. So if we take a look at the change in numbers, we have here manganese that's going from +7 down to +2. So we are gaining, manganese is gaining 5 electrons here. All right, so it's doing our reduction. All right, so here's our little summary. So manganese is decreasing from 7 to 2, so it's down 5 oxidation numbers, right? Oxygen is not actually even on the product side, and neither is hydrogen, but don't worry, that's part of us doing our balancing later. But if we look at sulfur, sulfur is going from -2 to 0. So meaning that sulfur is losing 2 electrons. And there's only one manganese and one sulfur, so we don't have to worry about like in the last example where we had to like add up all of the changes. This is exactly what it is. So we have sulfur that is doing oxidation, right? And it's losing 2 electrons. So we have one that's going down by 5 and one that's going up by 2. So remember, we want to have the ratio changed so that way it is making those values the same. So the lowest common multiple here would be 10. So what that means is for every 5 sulfur we would need 2 manganese. So what that means is you would put a 2 in front of manganese, this is actually, sorry, permanganate ion, but you would put a 2 here because we need 2 manganese, and we would put a 5 here because we need to have 5 sulfur. So you would then balance out the product side for sulfur and manganese. So if we have 5 sulfur here, we would need a 5 in front of the sulfur on the product side. 2 manganese, we would need a 2 in front of, 2 in front of this manganese ion. So what we've done right now is we've balanced out the charge change. We now have manganese that's going to lose 10, and we have sulfur that is going to gain 10. So the next step here is we need to balance out our oxygens and hydrogens. So let's check out how we're going to do that. So here are the coefficients like we just added in the last step. So now we're going to balance out the number of oxygens. So we are not going to change any coefficient numbers that are here currently. What we need to do is add waters where they're needed. So let's look at the reactant side. Here we have 4 times 2, so we have 8 oxygens, and there is no oxygens on the product side. So that's why on the product side we had to add 8 waters. You add 1 water for every oxygen you need. So because we have 8 and we had none, we're adding in 8 waters. That way we have 8 oxygen and 8 oxygen. So oxygens are done. What we're now going to do is balance out the hydrogens. So again, we're not going to change any coefficients of what we currently have. We don't want to change up. If we change something, it's going to throw everything we've done so far off. So we're going to count out our hydrogens. So we have 10 hydrogens on the reactant side. So 5 times 2, we have 10. And we have 16 on the product side because of those 8 waters. So that means to balance this out, we need 6 more hydrogens on the reactant side. So it would be 6 plus these 10 here. So that's exactly what we're going to do. So remember that to balance out the hydrogens, you're going to add in hydrogen ions. So now we have 10 hydrogen here plus 6 hydrogen ions, so that's 16, and that balances out with 16. So this is done, but here's a check. To make sure that you have everything properly balanced, I'll give you kind of a way to do that. What you have to make sure of is that the charges on the reactant side have to equal all the charges on the product side added together. Okay, so what I mean by that, the permanganate ion is a -1, but there are 2 of them. So this is like -2, right? So -2, this is no charge, so it's 0. And 6 hydrogens would be +6. So on this side, all together, we have +4. Over here on the product side, we have 0 for the waters because it's neutral, 0 for the sulfur because it's also neutral, and we have 2 times +2, which makes +4. So if your reaction is properly balanced, all the charges on the reactant and product sides should add up. This is a positive, not -14. +4, +4. All right. So sometimes when you're doing redox reactions, it may be in a non-neutral solution. So meaning, and it would have to tell you, of course, in the question. So it would say the following reaction is happening under acidic conditions or under basic conditions. If it doesn't say anything, you're going to assume that it's happening under neutral. So what we've been looking at so far would be like no conditions were listed, right? Now, what we've been doing so far is also the same if it was acidic. So this reaction, just to go back here for example, this reaction would be the same if it was happening in acidic conditions or neutral conditions. But if something is in a basic condition, and of course the question would have to tell you, what you're going to do is add 1 hydroxide ion for every hydrogen ion that you had to add to balance. And you don't even add it to just one side, you add your hydroxides to both sides. This is not going to make much sense until you see it happen. So hydroxide, let's say you had to add 5 hydrogens. That means on the reactant side you would add 5 hydroxides, and the product side you would add 5 hydroxides. For however many you had to add to balance the hydrogens, you add the same number of hydroxides to both sides. Then, if you have hydrogen and hydroxide on the same side of the reaction, what we're going to do is we are going to make water, because H and OH together is going to make H2O. And then lastly, we're going to cancel out whatever we can for the water on both sides. Okay, so again, it doesn't make much sense until you see it happen. Okay, so we have another example here. Balance the following in a basic solution using the oxidation number method. So what I want you to do is pause the video. I want you to try this out as if it's like following the rules of everything we've learned up till now, and then stop right before the basic solution part comes in. So I want you to assign oxidation numbers, see which one is reducing, which one is oxidizing, get the ratio down, balance the hydrogens and, oxygens first, then hydrogens, and then stop. Okay, and I'm going to show you the basic solution part.